Welcome to part 6. We will look at few more questions. So, if you have not yet subscribed, do so. 1,000 plus videos on various cloud certification areas. Let us look at this question now. Okay, so here is a question. So, what is the question? There is some kind of system, and they have uh, web servers and database. Web servers and database. So, web servers. Uh, See, for database, they have mentioned that it is getting utilized 80% usage. And who who uses that? Who is the culprit here? Who is the culprit? Read jobs. 90% of that is taken by read jobs. So read jobs are the culprit. So you have a database, people are firing select queries, people are firing reports out of it. So 90% of such activities are overloading the database. Okay, so you decided to improve the performance, and as a part of that, you have added cache. You see, you felt that reads, if 90% reads are there, I can provide cache, which is a good solution. I can provide cache. What will cache do? Cache will store a lot of data there so that every time read need not happen in the database. So you save some database effort. Database need not work so hard because cache will have that process data already. Okay. So now they are telling you was your workload will always keep growing. Do you want to change anything in this architecture? This is what we are going to do. So in nutshell, they have identified a problem. The problem is with the database reads, it is overloading. They are given a solution that I am going to put cache on top of it to solve the read problem. What else you think we should change here? See, the first thing immediately I'm saying is entire system is good. You web server and databases, everything was multi-AZ. Web servers, two AZs, RDS multi-AZ. But when you put cache you have just put single node. Why? Why, my friend? Who? So see, whenever you design as an architect, there should not be a single point of failure. We do not need single point of failure. Okay, like you have a family, parents, dad, mom, and two kids, but only the father is earning. That is a single point of failure. A lot of people you see they are poor because that single point of failure failed. The father expired early and the mom didn't have a lot of qualifications. So the entire family suffered financially, and that shapes up their future. So think from that context, real life context. Single point of failure as an architect should never happen. So even in your own life, if you're getting married, make sure your spouse is also uh, having skills, having good education, and some job experience. Okay, because she should be equal. Good for them if any failure happens. Okay, now, so what does that mean? Out of A, B, C, D, what we should do? We should do A. A is correct for me. What we should do is we should deploy the cache. We should deploy two clusters in different AZs. So because RDS will not be able to handle the load if cache node fails. Understood? If cache fails, if father dies, mother cannot carry the load. That is how you have to interpret it as I mean, from a financial perspective. So this should be the answer. Now let us analyze other options. So first, let me give you the description also. we have given a very detailed description so that you know you can pause and read this also. I have explained the same thing we have documented here. We are trying to add high availability of cache. We already have high availability of web server and database. So cache also should be highly available. And we have addressed this way the RDS overload issue. This is very beneficial. You can pause and read it if you want to focus more. So option B here, they are suggesting that if the cache node fails, no problem. The database will handle it because database is highly available. So this will not work. See, we already told that database is overloaded, and the question is already telling you that 30% more load is going to come. They are going to add 30% more load. So how will database handle? Okay, so this is incorrect. C is telling they are telling that boss you already have cache, elastic cache. So it has a feature. It is called node recovery feature. So it will prevent any availability impact. So if it fails, it will replace the failed node. So this feature, Elastic Cache Auto Recovery, Elastic Cache does not have auto recovery feature. First thing, there is no feature like this. And this, sorry, not does not, it does have, but the problem is that the recovery process takes time. Okay, uh, it does have, but the recovery process takes time. So now you might think, okay, if the recovery process takes time, so what is the problem? See, if at 1 p.m. the cache failed and the recovery is taking 20 minutes, that means till 1:20 you have no cache. Your database is screwed, your database will crash, your application will go down, you will lose those transactions, you will lose those customers. So is this a good option? No. Option D is telling boss, fantastic. You deploy Elastic Cluster with 2 nodes. So with 2 nodes is a good thing. The bad thing here is they are telling you to do on the same AZ. So what if the AZ fails? So your cache is still not highly available. So high availability, you should go on multiple AZs. Your RDS will get overloaded and crashed. So this is the rationale for the answer that we chose. So A should be our answer. A is our answer. We have to, we need 2 clusters in different AZs, not in same AZ. So this is the next question. There is an application and it is a multi-AZ. So you have this application getting supported by AZ1, AZ2, multi-AZ. Okay, there are 2 AZs. So when a failure happens, the client is telling, I need an RTO of 3 hours, less than 3 hours. That is recovery time objective and recovery point objective of 15 minutes. And the data corruption has already happened 1.5 hours ago. So how will we meet these objectives? So A says we will take hourly backups to S3 with transaction logs stored in S3 every 5 minutes. So this will help you with this 15 minutes RPO for sure. And RTO, it will also help you with that. So A is my answer. So you can read it. We are being very critical here. One problem we see with the question itself is that 1.5 hours has already elapsed. So if the data volume is high, you will not be able to meet the 3 hour RTO. But assume the data volume is mid-size or small, it you can achieve. So will this option is best because it minimizes data loss. Option B says, boss, I will uh, keep the sync on between master and slave. So when master got screwed up, slave also gets screwed up because that data got replicated here. At a face value, it looks a great option, but both instances now got screwed. It will not help you. C is telling we will take backups in EC2 instance store. The instance store is like your memory. If you store backups there, the EC2 instance is terminated, instance store is wiped out. When you restart, data is lost. So there is a durability risk here. It will not work. But who stores backups in ephemeral storage like instance store? It's temporary in nature. This is a stupid option. D. D says we will take backups and store in Glacier. See, if you try to restore from Glacier, the restoration process is extremely slow. So most likely your RTO will cross. So option A is our answer. So please subscribe. We are desperately looking for subscribers. There are 1,000+ videos on this channel on certifications, AWS, Azure Cloud, GCP Cloud, and become a cloud kernel member. You will have lots of parts posted there, which will elevate your chances of certifying. This was end of part 6. See you in the next part.